Crap. So, page 18 in your packets. All right. Shh. So, this lesson is one that you guys have technically seen before. We did this back in Unit 4, but now we're kind of expanding on it. So, back in Unit 4, I taught you guys how to simplify square roots. All right? Now I'm going to teach you how to simplify any radical, whether it's a cube root, square root, fourth root, whatever. And we're also going to be throwing variables into it. All right? Now, it's pretty much the exact same process. You just have to pay attention to what type of root you're dealing with. So, first, some vocabulary. So, the different parts of the radical. The little number that's like on the outside of the radical that tells you what type of radical it is, it's called the index. So, for example, a cube root has that little 3 on the outside that tells us it's a cube root. So, the index is 3. A square root has an invisible 2 right here. So, typically, there's an unspoken 2 right there for a square root. But it's so common that they don't even bother writing the 2. Now, the radicand is typically the number or value underneath the radical. And then the root is the value that you get when you evaluate the radical. So, for example, let's say I had the square root of 4. All right. The index would be 2 because it's a square root. 4 would be the radicand because that's what's under the radical. The root would be 2 because that's what the square root of 4 is, 2. All right. Now, another thing about the index is that it tells us in the radical how many times you have to multiply the root by itself to get the radicand. So, for example, let's say I had the cube root of 8, which is 2. That means on the flip side, since the index is 3 and my root is 2, that means 2 cubed is equal to 8. All right. So another example, the square root of 81 is equal to 9. 81 is the radicand. 9 is the root. The index is 2 because it's a square root. And then you multiply the root by itself twice to get the radicand. So 9 times 9, or 9 squared, equals 81. And again, it's pretty much understood in the math world that if it doesn't have an index, it's automatically a 2, meaning a square root. So if there's no index, it's automatically assumed that there's a square root. So on your test, if I have you write out radicals, you need to make sure that if it does have an index, like a cube root, you need to make sure you write that number, because if you don't, mathematically speaking, I take that as a square root, and it would technically be wrong. All right, so this is about precision. You got to make sure you include that number. It's important. All right, so let's try this. Now, that sheet that I gave you has all of the perfect cubes, squares, and fourths for 1 through 10. All right, so it's going to be a good reference for those numbers. So, cube root is 64. All right, what's the radicand? 64. It's the number under the radical. What's the index? 3. Now, what is the cube root of 64? 4. It's on that sheet that I gave you. All right. So if you look at the cubes, if you you look on the column, the cube column, find 64, look to see what number it's connected to. So that means if you have 4 times 4 times 4, or 4 cubed, be 64. Now this next one, a little bit different. What's the radicand? Come on, guys, what's the radicand?
32.
Not just 32.
X.
X to the 5th. Everything that's under the radical is considered the radicand. What's the index? 5. So this is a 5th root. Now, this is not on your sheet, but we have talked about this one before. What number times itself 5 times will give you 32? 2. Now, what value times itself 5 times will give you x to the 5th?
X.
X. So that means if we have 2x, 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 and 2x, or 2x to the 5th, make sure you put that in parentheses, you get 32x to the 5th. Now, your calculator can do this for simple problems, but some of them you got to figure out in your head. So the ones you really got to figure out in your head are the variable ones. But let's say numbers and you didn't know, like let's say you didn't know what the 5th root of 32 was. This is how you can find in your calculator. So I showed you how to find a cube root yesterday. No, 2 days ago. I showed you how to find a cube root in your calculator 2 days ago. But you can also find any type of root. So if you're finding any other type of root besides a square root or a cube root, here's what you do. You first input the type of root you want, or the index. So in this case, 5. Then you're going to go to the math key, which is under that green alpha key. Now, do you see right here where it says has a little x and then a root? All right. This means that you can make any type of radical that you want, 5th root, 4th root, 100th root, whatever. All right. So if you hit 5, that's why you had to type the 5 first. If you hit 5, it'll take that 5 that we already typed and make it your index for the radical. And then we can type in 32 underneath. And it is, in fact, 2. Now, remember, cube roots you don't have to do this for, because if you hit the math key again, 4 is already a cube root. So you can just click 4 and that'll input the cube root for you. So 64, 4. Now, let's see if you guys can figure these out. Now, something else to consider. If you have an even index, meaning it's an even root, so square root, 4th root, 6th root, you can have no negatives under the radical. Why? What happens if we have a negative under a radical? So, for example, a negative under a square root. What happens if we have a negative under a square root? Put the phone up. So if we have a negative under a square root, what's the issue? We talked about this back in Unit 4. It's imaginary. Good. So if you have a negative under the radical, remember, it's not a real number, it's imaginary. So you got to take an I out. Now, that is not true for odd index. You can have a negative under the radical. because what it does is it just means your answer is negative. So cube roots, for example, if I had the cube root of -8, the answer is -2. Because if you think about it, -2 times -2 is +4, times another -2 is -8. So odd indexes, you can have a negative under the radical. Your answer is going to be negative, so it'll still be real. Even index, just note that technically, if you have a negative under the radical, it's unreal, meaning you'd have to take an I out. All right. And again, you won't really see that much unless it is a square root. So if it's a square root with a negative under the radical, I expect you to take that I out. All right, so let's look at number 1. Now, you can use that reference sheet that I gave you for this. What is the cube root of -1000? -10. Good. Cube root of 1000 is 10. If it has a negative under the radical, it means your answer is negative. Now, they want the plus or minus answer of the square root of 144. So remember, we default to the plus, but they want both. So it's plus or minus what? You guys should know this one. 12. All right. So this one, they already have the -2, so we're going to multiply that to whatever our answer is. And what's the square root of 49? 7. So that would be equal to -14. Now, review from last unit. Square root of -25. It's not -5. It's not +5 either. What did we just say up here? Isn't a square root an even index? Yes? No? Yes. So we have to do what? We got to take an I out because it's going to be imaginary. So this will be I square root 25. So what's the answer? 5i. So again, negative under a square root, you've got to pull the I out. It's not a real number. Now, number 3 will be a real number. What's the 5th root of -32? Not just 2, -2. Because it's an odd index. Now, let's throw some variables into things. So, think about this carefully. The square root of x to the 4th. Now, any even exponent is technically a perfect square because the way that you deal with exponents, let's say that we converted this to our fractional exponents. It's a lot easier to see this way. So if I convert this to a fractional exponent, what would it look like? So remember when we did this like 2 days ago? How do I convert from a radical to a fractional exponent? You guys got this thing called notes. Look at them. So how do I change from a radical to a fractional exponent? This was 5.2. How do I change from a radical to a fractional exponent? So it's going to be x raised to the something something. And it's going to be a fraction. What goes in the numerator of the fraction?
1.
Nope. No, you're guessing. Okay. All right. Guys, it really ticks me off when I already taught you this and like you can't tell me. So if you go back to your notes right here, how do I go from a radical to a fractional exponent? So this is what we had. So it looks like this. How do I go from that to this? It's what? 4/2. You take whatever the power is and put it over the index, which is an unspoken 2 there. You got to know how to do that. So if I converted this, this will be 4/2. Well, what's 4 divided by 2? 2. So your answer is x squared. The other way you could think about it is that since this is a square, you're looking for 2 factors that I'll multiply to give you x to the 4th. That can only be x squared and x squared. All right. So this next one, what do you think the square root of 81x to the 20th is? What's the square root of 81?
9.
So the first part of your answer is 9. So we got 9 square root of x to the 20th. Let's convert that to a fraction. So what would that be as a fractional exponent? 20/2. So this would be 9x to the 20/2. So what is it? 9x to the what? 10. So essentially, guys, if you're taking a square root, you just divide the exponent by 2. That's what I'm getting at here. Now, number 8. First off, there's something that I don't even have to worry about. What's something that I can just kind of go bye-bye? Z to the 0. Why? It's not 0. It changes to 1. So that goes away. Now, let's say I rewrote this as square root of x squared, square root of y to the 22, which we can do. We talked about that when we were simplifying radicals in unit 4. So if I convert both of those to fractional exponents separately, what would it be for x? X 2/2. What would it be for y? 22/2. So this would be what?
X, Y, 24/2.
Nope. 11. 22 divided by 2 is 11. 2 divided by 2 is 1, so there's an unspoken 1 here, but you technically don't have to put it. All right. Last one. So the negative 2 is on the outside, so whatever we pull out, we're going to multiply to negative 2. So let's do the numbers first. So what's the square root of 16?
4.
4. And then I'm going to separate the other two. So a to the 10, b squared. So if I convert these two to fractional exponents, so this would be negative 8 times, what's a? 10/2, good. And then what's b? 2/2. Y'all good?
Yeah.
Gonna knock my water.
All right. So, what do you guys think? Someone who has not talked yet. What do you guys think the answer is? So, you know we're going to have -8. What's the A? A the what? Fifth. Good. What about B? B the what? B to the 1. So there's an unspoken 1. You don't technically have to put it. All right. Now, all the ones we've done so far are flat out perfect squares. All right. So I want you to take a moment, try those next 2 on your own. Now remember, for the big one, if it's not on that reference sheet that I gave you, you can always put it in your calculator. But for the first one, the 4 through 1296 is definitely on that reference sheet that I gave you. So I want you to stay with the radicand is, the index, and the root. My recommendation, convert this to fractional exponents will help. So try both of those.
This one it should be.
Oh, right, okay.
So the rest of it's
You kind of solve.
So that's just
Brain fractions. You did a great job with the focus, right? But then you have to make sure that it's and the forward. You're right, and the entire thing, or is that right? You've got the equation on the right, you've got number right.
same thing.
It's not coefficient for your brain.
I remember Miss Rose calling her Miss McFlips.
Come on, guys.
When we did this, we just talked about your index was 2. Here.
No.
All right, so I'm gonna do
I was saying.
our index is. That's where I'm What's your exponent on your index? And your index is. I know.
Alright guys, I'm gonna give you about 1 more minute on your own. And I'll have you guys come together with your groups.
So that's the rest of your documents, but the index is ready. What's the use of
Oh, come on.
You should know that. We'll give it.
Alright guys, looks like most of y'all finished up, so go ahead and compare answers with your group mates.
I meant to write 418. Be quiet. My brain was right. I just wrote it wrong. My mind was moving fast in my head.
In a long time, I'm pregnant.
Alright, let's come back together. So, Alright, so, Carolina, what's the radicand for the first one? And m to the and good. So remember, the radicand is everything under the radical. So what is the index? Owen.
The index is 4.
Good. It's a fourth root. Now, for this first one, the root is going to be the fourth root of all those values. But some of you were struggling with that. So I'm going to ask for someone for the numerical root, and then I'll do one of the variable roots with you, and then ask someone else for the other one. Okay? So what is the fourth root of 1296, Nick? All right, so it is 6, but you have to mind your types of roots. So m squared and n to the fourth is if it was a square root, but this is a fourth root. So, so separating these into their own individual root really helps you guys see it. So let's say I have the fourth root of m to the fourth. How would I convert that to a fractional exponent? Anyone? What's the power? 4 over 4, because the index is also 4. So remember, index goes in the denominator, power goes in the numerator. So if I simplify, so instead of the denominator being 2, like it is for a square root, this is a fourth root, meaning the denominator has to be 4. So what is the fourth root m to the fourth? M to the first, yes. So if we follow that same logic, what do you think the fourth root of m to the eighth is? Not just 2, n squared. Right, because n to the eighth, this would be n, not m, n to the 8 over 4, or or just n squared. So guys, if it helps, take the time to just write them out separately and convert them to fractional exponents. The better you get at doing that, the easier you'll be able to see it when you have, and you can do it in your head faster. All right, so the root is 6mn squared. All right, 2. So what is the radicand, Chris? Good. What is the index, Luke? 2. Good. It's the square root. Unspoken index is the 2. Now, we have talked about this, so I want the full root. So what is the full root? Ephraim. Mm-hmm. So not 6. So it's a square root. So now we're dividing by 2. So what's the square root of 144?
It's 12.
12. And then v the what? 4th. Good. So you would divide the 8 by 2. Now, that kind of leads us into what we now call the factor tree. So I kind of spoke on this back in when we were simplifying square roots. It's a useful tool for when you're trying to break down everything. So the way the factor tree works is that you break down the numbers and your variables into its kind of base properties. All right. So I always do like the numbers on their own, the variables on their own, because it's just easier. All right. So for 1296, can someone tell me 2 factors of 1296? And you can use your calculator. So in other words, 2 numbers that divide evenly, or 2 numbers multiplied together that divide evenly to 1296. What's an obvious one? Well, besides 1. So the purpose is you don't want 1. It's an even number, right? So it can automatically be divided by 2. So 2 times what is 1296?
648.
648. Now, when you're doing a factor tree, you want to break it down to its prime factors. Can anyone tell me what a prime number is? So what's a prime number? Who remembers? Owen.
Isn't it like a number that like multiplies by only like 1 and itself or something?
Close. It's dividing by 1 in itself. So a prime number is a number that can only be divided by 1 and itself. In other words, its only factors are 1 in itself. So out of those 2 factors do I have a prime factor there? So is one of those 2 numbers a prime number? Which one? 2. The only 2 factors of 2 are 1 and 2. So it's a prime factor. Meaning we can break down the 648. So how can I break down 648? Anyone?
You can break it down in 2 and 324.
Yep, still an even number, still can break it down by 2. Sometimes the easiest, most obvious one is just the easier way to go. All right, 2 is still prime, 324 is obviously not. How can I break down 324? Divide by 2 again. So what is 2 divided into 324? 160 what? 2. 162 is clearly not prime. Keep going. Divide by 2 again. All right. 2, and how many times does it go into 162? 81. Now, is 81 prime? Oh, no, it's not. So we got to break down 81. Now, we can't divide by 2 anymore, but we can divide by what? What are 2 factors of 81? I mean, yeah, 3 and 27 works, or 9 and 9, because it's a perfect square. Let's do 3 and 27. Which one's prime? 3. Now, you didn't have to use a prime number in one of your factors when you find it. You can use any factors. You just have to recognize which ones are prime. So if you use 9 and 9, you had no prime factors there, and you just had to break down both of those numbers. How do I break down 27?
3 and 9.
3 and 9. 3 is still prime, 9's not. How can I break down 9?
3 and 3.
3 and 3. So you're done when the bottom of your tree is all prime. All right. Now, why do we care about this? How this helps us is that it can kind of show us where our fourths are. Because a perfect fourth is defined as what? So a perfect fourth is defined as what? How do we know if a number is a perfect fourth? Just like a perfect square. So guys, if you raise something to the fourth power, what are you actually doing? Come on, guys. If you're raising something to the fourth power, so like to the fourth power, what are you actually doing? Multiplying by itself 4 times. So a perfect fourth is a number that when you take the fourth root, will give you a number that's multiplied to itself 4 times. So that means we're looking for numbers repeated 4 times, or groups of 4. And we're looking specifically at the prime numbers. So, looking at my circled prime numbers, that's why I circled them. Any groups of 4? So is there any numbers that are repeated 4 times? 2 is one of them. And 3 is the other one. So when I come back to my prime factor tree, all right, I can rewrite this fourth root as 2 to the what power? 2 to the what? How many times do we multiply by 2?
4.
4 times. 3 to the what power? 3 to the fourth. All right. Now, m to the fourth. All right. M to the fourth, how many m's actually are there? 4. All right, so we're going to still put m to the fourth. And n to the eighth, we know that's also going to have 2 sets of 4 because there's 8 n's. So think about this logically. What would be the fourth root of 2 to the fourth? So if I separate this now, I have the fourth root of 2 to the fourth times the fourth root of 3 to the fourth times the fourth root of m to the fourth times the fourth root of n to the eighth. What's the fourth root of 2 to the fourth? So guys, if we're taking the fourth root of a fourth, what's going to happen to each other? They're going to cancel out. So what do we have left? 2. So I have 2 times, what's the fourth root of 3 to the fourth? 3. What's the fourth root of m to the fourth? M. Now be careful with this one. Fourth root of n to the fourth, or n to the eighth. N squared. Because if you convert that to a fractional exponent, it'll be n to the 8 over 4, which is n squared. So if we multiply everything together, 2 times 3 is what? 6, and then m n squared. Is that not what we got up top? Because it was the same answer, same problem? Yes, it is. So, in other words, if that number was not on that reference sheet that I gave you, that's how you can break it down. Whatever the index is, that's the number of group, that's the number of numbers that should be in one group. All right, and it has to be the same number. Okay, so if it was a square root, you will be looking for pairs. If it was a cube root, you'd be looking for groups of 3. Fifth root, groups of 5. Does that make sense? And then you can rewrite it using that number raised to that power, because then it's really easy to get the roots. So that's exactly how this works. So how to simplify using a factor tree? You first make the factor tree. You group the factors according to the index. So in other words, you group it into groups according to the index. And remember, they have to be the same number to be in a group. And then you pull out one value of each group or rewrite it like we did. I suggest rewriting it for you guys because it's easier to see if you rewrite it. There's less room for error. All right. So now, let me ask you this. Not every problem will work out nicely, just like how not every square root worked out nicely, not every fourth root will work out nicely. Is 48 on that list of perfect fourths that I gave you? No. So it's not going to be nice. All right. So if you put it in your calculator, so put in your calculator that fourth root like I showed you. So put 4, math, and then hit the number 5, and then put 48. What will be an approximation? It's what? 2.6. Keep going a little bit. 3, 2, 1. And I'll stop there. And it'll keep on going forever because it's an irrational number. All right. So if we want to break this down into its simplest form, they told us that's going to be 2 fourth root of 3. But let's actually look at the factor tree for that. So let's break 48 down to its prime factors. So first off, let's start simple. What are 2 factors of 48? 2 and 24. Which one's prime? 2. My recommendation, circle your prime numbers so you don't mix up. All right. Now, 24. Any 2 factors of 24? 2 and 12. 2 still prime. Factors of 12. 2 and 6. And factors of 6. 2 and 3. Both of them are prime. So again, once you have all prime numbers, you're done. So how many numbers am I looking for in a group? 4. So what number is repeated 4 times? The 2's. Now, this 3 is what's left over. It doesn't go away. It's still going to go back under the radical, just like how when we did square roots. So this 3 is going to be this 3 is going to be what we put left over. So if we go back under the radical, how can I rewrite 2 times itself 4 times? 2 to the 4th, and it's still times 3. All right. So if I separate this, this will be 2 to the 4th, 4th root, and then the 4th root of 3. So I'm just breaking up the radical. So what's the 4th root of 2 to the 4th? 2. Times, we can't take a 4th root of 3, so that's left over. So that's how we get 2 4th root of 3. Now, the other way you could do it is just like how we did square roots. find the largest perfect fourth that's a factor of 48. So if you look at that list of perfect fourths, what would be the largest number that's technically a factor of 48? So look at, it's what?
16.
It's 16. So if I break that down to 16, and 16 times what is 48? 3. I could rewrite this as the fourth root of 16 times 3. Fourth root of 16 times the fourth root of 3. What's the fourth root of 16?
4.
Not 4, that's the square root of 16. Fourth root of 16 is 2. Fourth root of 3. So you still get the exact same thing. It's really whichever method you prefer. Now, remember, some numbers, this is what throws a lot of people off. Some numbers can be both perfect squares and they're also perfect other numbers. So like, for example, 16 is also a perfect fourth. 81, which is a perfect square, is also a perfect fourth. All right, so you've got to really pay attention to what their radical is. All right. So here are some other examples. So we know how to simplify this type of radical. It's just a square root. So what's my first step for simplifying a square root? What's the way that I taught you? You find the largest factor that's a perfect square. All right. You could also do a prime factor tree if that's more your cup of tea. All right. Which one do you want me to do? Prime factor tree or the perfect square method? Perfect square? Okay. So what's the largest perfect square that'll go into 12?
4.
4. 4 times what is 12?
3.
3. So I can rewrite this as the square root of 4 times the square root of 3. What's the square root of 4?
2.
2 square root 3, which is what they got up here. We can do the same thing with perfect cubes. So do you want me to do a prime factor tree or do you want me to do the perfect cube method? You know what? I'll do both. So 24, let's do prime factors first. What's some factors of 24? 3 and 8. All right. Is one of those prime? 3 is. How can I break down 8? 4 and 2. I'm going to put 2, 4. 2 is my prime. How do I break down 4? 2 and 2. Now, since it's a cube root, I'm looking for groups of what? 3. So do I have a group of 3? The 2's. Now, don't forget about the little 3. Make sure you always include all your prime factors back under your radical, even if it's not a group of 3. All right. So if I go back under my radical, I have the cube root of 2 to the what? 2 cubed times 3. And I'm not done because I still got that x to the 5th. All right. So let's think about this logically. If I wrote this out in expanded form, I have x times x times x times x times x. So how many groups of 3 do I have in that? 1. So just 3 x's. But we still got these 2 left over. So the 3 x's would be x cubed. All right. What would the 2 x's left over be rewritten as?
X squared.
X squared. So if I break this down into all of its cube roots, I got the cube root of 2 cubed times the cube root of 3 times the cube root of x cubed times the cube root of x squared. Which are the only 2 radicals in this multiplication statement that are perfect cubes, meaning we'll get nice whole values? These two. So we're going to do those first. What's the cube root of 2 cubed? 2. These go away. All right. Cube root of x cubed. X. And I'm left with, I'm going to combine these two non-perfect cubes. 3 times x squared. So my answer is 2x cube root of 3x squared. And that's it. Now, it really looks like a lot of work, but honestly, you can kind of eyeball it. Like, for example, x to the 5th, how many, x's can you have to make a group of 3? How many groups of 3 can you make out of 5 x's?
1.
1. So it'd be x cubed, and then it's however many you have left over. So you just subtract 3 from 5. All right. Now, product rule, we've already talked about that. We've already been doing it. It's when you can take multiplication that's under a singular radical and break it into separate multiplication, or vice versa. So, let's do this. So, square roots. All right, let's do it the way we've been doing it. So, what is the largest perfect square that can go into 8? 4 and 2. All right, so I can rewrite this as the square root of 4 times the square root of 2. So what's my answer? 2 square root 2. All right. 18. What's my largest perfect square that can go into 18? 9. 9 times what's 18? 2. Now, it's a square root, so we're looking for groups of what? 2. So, how many groups of 2 can I get out of x squared? I mean, not x squared, x to the 7th. How many groups of 2 can I get out of x to the 7th? 3. So, in other words, if you wrote it like this, it's 3 sets of x squared, or just x to the 6th if you want to do it that way, and then a singular x left over. So that's how I'm going to write it. I got the square root of 9 times the square root of 2 times the square root of x to the 6th times the square root of x. Because remember, these 3 together, if you multiply them, is x to the 6th. So, what's the square root of 9? 3. Square root of 2 we can't take. Square root of x to the 6th? X cubed. So if you convert that to a fraction, it'd be x to the 6 over 2. So that's 3. And then the square root of x we can't take. Now I'm going to reorganize it so that my non-radicals are with my non-radicals and my radicals are with my radicals. So this will be 3 times x cubed square root of 2 times x. I'm going to combine the square roots again. So my answer is what? Square root of what? There you go. Now again, guys, I'm writing out all the steps. You don't necessarily have to write out all the steps. All right? But until you get good at it, I highly recommend it. All right, let's try another one. 20. What's the highest perfect square that can come out 20? 10's not a perfect square. The highest perfect square that's a factor of 20. 4 and 5. So this can be the square root of 4 times the square root of 5 Now we're looking for groups of 2. How many groups of 2 can I get out x to the 15th?
6.
6. So in other words, how many? It would be x raised to the what power if I get 6 groups of 2? What's 6 times 2, guys? 12. So this would be x to the 12th. How many's left over? 3. X cubed. How many groups of 2 can I get out y to the 9th?
4.
4. So what's that written as an exponent? Y to the, not y to the 4th. So if you can get 6 groups, multiply that by 2, that means your exponent's 12. If you can get 4 groups, multiply that by 2, that means your exponent's what? 8. So y to the 8th, how many's left over? Y. That's how you logic your way through this. Does that make sense, guys? Okay. So now we can do some simplifying. What's the square root of 4? Square root of 5 we can't take. What's the square root of x to the 12th? Not 4. 6. Because remember, it's x to the 12 over 2. If you need to take that step and rewrite it like that, that's fine. X to the 6. Square root of x cubed we can't do. What's the square root of y to the 8th? Y to the 4th. Because 8 over 2. What's the square root? And we can't take the square root of y. So if I rearrange with my radicals and my non-radicals with my non-radicals, what's my answer? So it'd be 2 what? X to the 6, y to the 4th, square root what? Y. Good. So that's kind of what you do at the end. You combine all of your non-radicals. So these are all my non-radicals, which we got here. And then you combine all of your radicals, which we got there. Does that make sense? Yes, no, maybe? Yep. All right. Now, let's try one where we're doing cubes. All right, so pay attention to the index. The index is 3. So instead of groups of 2, we're looking for groups of what? 3. So, first off, is -8 a perfect cube? Yes, so that one's easy to do. All right, so we can leave out the cube root of -8. We don't have to break it down. So if you can recognize a perfect cube, you can just go ahead and take it out. How many groups of 3 can I make in 15? 5. Is there any left over? Nope. So R the 15th is by itself. How many groups of 3 can I make in 9? 3. Are there any left over? Nope. So T the 9th. So what's my answer? What's the cube root of -8? -2. Cube root of R to the 15th?
5.
R to the 5th. Cube root of T to the 9th?
D the
3. T to the 3rd. That's my answer. The cube root's gone. So guys, does it help actually like separating it and everything and doing things like that? All right, let's try another one. So, is 16, or -16, I should say, a perfect cube? Yes, no, maybe? No, -16 is not a perfect cube. It's not on that list I gave you. So that means we got to break it down factor tree style. Or we can figure out what the highest factor that is a perfect cube that can go into negative 16. Which one do you want to do, the factor tree or the other way? Let's do the factor tree. So, factors of 16. 2 and 8. So I got 2 and negative 8. I'm going to break down the negative 8. 2's prime. Factors of 8. 2 and 4. So I'm going to make the 4 negative. Factors of, so it'd be 2 and negative 2. And then negative 2 is technically not prime just yet. Factors of negative 2. 2 and I'm going to go negative 1. So in other words, if you got a negative, get it down to negative 1. All right? Because that'll help, especially since this is an odd. It's an odd index, meaning our answer is going to be what? Whatever we pull, we technically can still pull the negative out. Because negative 1 is technically a perfect cube. All right? So how many groups of 3 do I have? I have 1 group of 3, and that's my 2's. I still have the 2 left over, and I still got the negative 1 left over. All right. So if I rewrite this, I currently have the cube root of 2 cubed times the cube root of 2 times the cube root of negative 1. How many groups of 3 can I make out of x to the third? So how many groups of 3 can I get out of x to the third? 1. So is x cubed a perfect cube? Yes, so I can just rewrite it. How many groups of 3 can I get out of y to the 17th?
5.
5. All right, so that means it'll be y to the what? If I can get 5 groups, that means it's y to the what?
To the 5th.
Nope. 5 groups of 3, guys. That means it's y raised to the what power? Guys, what's 5 times 3? 15. That's how you think about it. All right, if you can get 5 groups of 3, how many y's is that? 15. All right. Times, how many do I have left over if I take 15 out? 2. So, let's go through the motions. What's the cube root of 2 cubed? 2. Cube root of 2 we can't take. What's the cube root of negative 1? It's negative 1. That's why I said pull out that negative. What's the cube root of x cubed? X. Cube root of y to the 15th? So this would be y to the 15 over 3. So that's what? Y to the 5th times the cube root of y squared. So if I pull everything together, I got negative 1 times 2 times x times y to the 5th times the cube root of 2 times y squared. So what's my answer if I simplify? What's negative 1 times 2?
Negative 2.
Negative 2 x y to the 5th cube root of what? What's under the radical? 2y squared. All right. Try number 6 on your own. Keep in mind, it's a what type of root? It's a fourth root, meaning you're looking for groups of what? 4. All right, give it a shot. So my recommendation, break down prime factors. Well, even if you did use 8 and 4, you just break it down. You can make more than 4, right? Now think about working some gates.
Say no, say no. No.
They have that one too. Nothing about
As long as
I mean, I
you
do.
as long as you say it, as long as you go to the.
Zero.
All right, guys, let's go over this real quick before class ends. All right, so 32. How many groups of 4 did you have, and of what number? You broke it down. 2. Well, no. How many groups of 4 did you have out of 32? And what number? Oh, good Lord, let's do this way. I'm confusing myself. Okay, 2 and 16, 2 and 8, 2 and 4, 2 and 2. How many groups of 4? 1. It's just one set of the 2s. I have this one left over. So this would be 2 to the 4th, because that's what that is 4 times. Times the 4th root of 2. How many groups of 4 can I make out of x to the 8th? 2. Is there any left over? Nope. Perfect 4th. How many groups can I make out of y to the 9th? 2. So if I can make 2 groups, what's that as a perfect 4th? 2 times 4, guys. 8. Y to the 8th. And I'm left with what? 1y. All right, the z's. How many can I make? 1 group, so that'll be z to the what? What's 1 times 4? 4. How many do I have left over? 3. So z cubed. Don't back up yet. I'm still teaching. So, what's the 4th root of 2 to the 4th? 2. What's the 4th root of x to the 8th?
X to the 4th.
Nope. This is x over 8 over 4. So it's x what? Squared. 4th root of y to the 8th. Y squared. Come on, guys. 4th root of z to the 4th. Just z. It's z of 4 over 4. And then we're going to just rewrite all the non-perfects back underneath the singular radical. So your answer is 2x squared y squared z to the 4th. No, not z to the 4th. Z. 4th root of 2y z cubed. Now, there is a new Delta Math, but it goes along with the lesson from today and then the lesson you'll learn on Monday. So you should be able to do all the ones that say simplify radicals. All right?